It's just a matter of weeks before the unique interstellar comet known as 3I Atlas is expected to pass closest to the sun between the orbits of Mars and Earth. Harvard astrophysicist Avi Loeb has suggested the 3I Atlas is actually some type of alien technology sent here from another solar system.
And so begins a journey not of distance, but of understanding. This isn't the first time we've glimpsed something from beyond the borders of our cosmic neighborhood, but never has a visitor moved with such eerie elegance, such precision slipping through gravitational fields, like it knows the language of the solar system better than we do. While most comets stumble through space with chaotic tails and icy sputters, 3 Atlas glides, measured, purposeful, quiet, as if it were watching us. NASA first called it harmless, and by all traditional metrics, island. It's not on a collision course with Earth. It's not spewing radiation or breaking apart in fury. Its projected path, according to early observations, puts it millions of kilometers away from any planetary body, a ghost in the sky. But not all ghosts are aimless. Some return for a reason. With each passing day, new data emerged. Orbital projections began to shift, subtly, then consistently. Each recalculation bent its path, a little closer toward Mars. Not dramatically, just enough to raise eyebrows among astronomers who know the quiet signs of something unusual. Avi Loeb, never one to shy away from cosmic controversy, pointed out that this wasn't normal behavior. Natural comets don't tighten their trajectories like this. They don't course correct in a way that consistently narrows toward a planetary orbit. It's not just about gravity anymore. It's about intention, or at the very least, the illusion of it. And if nature doesn't do that, something else might be. Adam Hibbard, one of Loeb's students, ran the models. According to his calculations, all it would take for 3I divided by Atlas to intercept Mars is a nudge, a mere 10 kilometers per second of additional velocity. A feather's push in cosmic terms. It could come from natural outgassing. Yes, the gentle venting of frozen material as the comet warms near the sunday. But the numbers told another story, because the timing was too perfect. The trajectory kept aligning. Each fresh batch of data moved the predicted closest approach not further, but closer, shaving off distance like a sculptor refining the arc of a blade. First, it was 29 million kilometers, then 10, then less. By the 26th of September 2025, the new projection had it swooping just 1.95 million kilometers from Mars. To the casual eye, that's still an immense gulf, but in planetary terms, it's a brush of the fingertips, especially when the object in question is already adjusting itself. Not randomly, but rhythmically. 17 minutes. That's the heartbeat. 3 Atlas has been pulsing carbon dioxide jets, like clockwork, exactly every 17 minutes. Not 16.9, not 17.1, precisely. Like the ticking of an old grandfather clock in the dark halls of the universe. Regular, unwavering, eerily mechanical. Spectroscopic data from the Gemini South Telescope in Chile confirmed it. The emissions weren't chaotic plumes, they were jets, firing in a consistent pattern, measured bursts that nudged the object, ever so slightly, in just the right direction, toward Mars. And that's when something changed. Not in the comet in us, because comets don't behave like this. They don't pulse on schedule. They don't drift toward planetary orbits with this kind of precision. And they certainly don't maintain machine-like rhythm while flying through the solar system at over 87 kilometers per second. Suddenly, the silence became deafening. Observers from NASA's Mars Reconnaissance Orbiter caught the comet doubling in brightness, not gradually, but instantaneously. A sharp ultraviolet spike, a flash, like something waking up. Across Earth, amateur astronomers began seeing it too strange. Needle-thin tails forming, all pointed toward Mars, pulsing in unison, all synchronized to the same impossible rhythm. 17 minutes. Always 17. It was no longer just a comet. It was a metronome in space. A signal, a pathfinder, a machine in disguise. And then came the radar. Goldstone's high-gain antennas bounced signals off the object's surface, expecting a soft echo from icy dust. What they got instead was metallic reflection. Sharp, clean, like radar bouncing off a submarine hull. Not the signature of ice or rock, but of alloy. Alloy that shouldn't be there, at least not if this was natural. Then came the chemistry, and the mystery deepened. Spectral analysis revealed something else. Nickel, but no iron. On Earth, that's a smoking gun. Nickel without iron doesn't occur naturally in space. You can only get that through industrial processing, a manufacturing process known here as the carbonyl method used to create specific alloys in spacecraft and heat shields. It was no longer a theory. It was a question the universe had placed squarely in front of us. Are we being studied? Loeb's hypothesis was gaining traction, that this wasn't just an object, it was a probe, not an emissary, not a warship, but a silent scout, a traveler from another civilization, obeying the first law of the dark forest theory: stay hidden, stay silent, observe from afar. And yet, this one had been noticed, because maybe, just maybe, it wanted to be. Now, in the final weeks before its closest approach, we stand on the edge of something far greater than a planetary alignment. We are about to witness an event that could redefine what it means to be alone. Because if 3I divided by Atlas is what some believe it is, it didn't come here by mistake. It was supposed to be uneventful. That's how the first reports framed it. A comet from the stars, sliding gently through our system on a one-way trip back to the void. Nothing new, nothing alarming, just another icy relic from the outer dark, passing by like a stranger who doesn't stop walking. But the universe has a way of whispering secrets before it screams them. 3I divided by Atlas wasn't just a name, it was a wound in the silence, a question dressed in comet dust. From the moment it was spotted, its path was strange, not wrong, just too perfect. Initially, astronomers calculated its closest approach at around 29 million kilometers from Mars, far enough to ignore, too far to fear. For reference, that's hundreds of times the distance from Earth to its own moon. Plenty of room, safe, clean, but space does not respect comfort zones, it respects momentum, and momentum began to shift. As more data streamed in, something unnerving happened. The predicted path of 3I divided by Atlas didn't stabilize, it tightened. Like a thread pulled from the fabric of space, the object's trajectory began to draw closer and closer toward the red planet. Not wildly, not chaotically, but subtly, millimeter by millimeter, recalculation by recalculation, as if the solar system was being played like an instrument, as if someone was fine-tuning a note. By late August, the new prediction placed the comet within 1.95 million kilometers of Mars. Still not a direct hit, but no longer dismissible. Especially when the shift wasn't random, it was directional, purposeful. Think of this. In the great cosmic void, a rock should drift like a leaf in the wind. 3I, divided by Atlas, was gliding like a shark in water, eyes forward, intent beneath its silence. Scientists noticed something else. Its orbital plane, the invisible surface along which it travels, began aligning with Mars's own orbit, not by accident, but through tiny, measurable shifts. Not enough to scream, but enough to suggest that someone or something was correcting the angle. This is where Adam Hibbard's work becomes critical. The Harvard researcher crunched the numbers again, and what he found shattered the illusion of safety. He calculated that the comet would only need a delta V, a change in velocity of 10 kilometers per second to intercept Mars. That's not much. For a spacecraft, it's a leap. But for an interstellar object already traveling at nearly 90 kilometers per second, it's barely a push, a breath in space, a correction, a choice. Comets don't typically change course. They are governed by ancient forces, gravity, inertia, outgassing. But when outgassing happens, it's messy, unpredictable, volatile. It's ice boiling into vapor and pushing jets in random, chaotic spurt. 3I divided by Atlas wasn't boiling, it was pulsing. And the pulses had rhythm every 17 minutes. Exactly. CO2 jets, measured down to the second. firing from the comet's tail in a machine-like cadence, each burst small, but together, they worked like reaction thrusters, nudging the body closer to the target not just in space but in alignment. To anyone watching with understanding, it looked less like a natural outburst and more like maneuvering. Let that land. This isn't science fiction. This is data. This is observational astronomy, intersecting with unnerving precision. When a rock from another star system behaves more like a spacecraft than a comet, when its behavior is repetitive, rhythmic, and mathematically effective, you start to question everything. And you should. The most recent models show that between September 19th and 30th, 2025, a narrow window opens a tipping point. During that time, even a small lateral push from one of these gas jets could reduce the closest approach distance to under 50,000 kilometers. That's within Mars's gravitational influence. That's no longer a near miss. That's within range. Gravity would do the rest, pulling it in, drawing it close, turning a traveler into a projectile. But here's the haunting part. All this is happening quietly. No fire, no flash, just trajectory, just physics, just the slow, spiraling whisper of a celestial object finding its way towards something ancient and red. NASA knows, so does Harvard, so do the observatories watching its tail flicker every 17 minutes like a metronome of intent. They've stopped using words like harmless. They've started using phrases like close monitoring and behavioral anomaly. And yet the public narrative remains calm. Because how do you tell a planet that something from beyond the stars is behaving like it wants to make contact? Or worse, like it doesn't care if it does? You tell them gently. You wrap it in phrases like low probability and interesting trajectory shift. But beneath the math is a simple, primal truth. Something's coming. And if it chooses even slightly to change its course just a bit more, then what began as a curiosity from another star could end with a crater on Mars so large, we'd be able to see it from Earth. If it happens, if it chooses, because the deeper truth now haunting every astronomer watching this object isn't whether it will hit, it's whether it's deciding. There is a difference between noise and rhythm. One is chaos, the other is intent. In the silence of space, few things pulse, most things drift, spin, decay. But when something begins to repeat itself with unerring precision, not once, not twice, but over and over, for days the universe stops sounding like a void and starts sounding like a clock. That's what 3E Atlas has become, a clockwork phantom, 17 minutes. That's the interval. Every 1020 seconds, a carbon dioxide jet bursts from its body, not randomly, but with metronomic consistency. Like the second hand of a cosmic timepiece, it doesn't slow, doesn't drift, doesn't deviate, not by a millisecond. First spotted by the Gemini South Telescope in Chile, these jets weren't chaotic plumes of evaporating ice. They were tight, linear, focused, released in pulses that consistently nudged the comet's velocity just enough not to slow it, not to speed it up, but to subtly shift its trajectory. A course correction every 17 minutes. Comets don't do that. Even the most active of them belch and spray with the whim of solar heat, spewing irregular clouds of gas and dust as their frozen cores fracture under the sun's relentless gaze. But 3E Atlas, it doesn't belch, it breathes. Inhalation, exhalation, 17 minutes on the dot. The question isn't whether it's releasing gas. The question is, what's controlling the valve? Because a mechanism seems to be operating behind the veil of ice and dust, a behavior that echoes not geology, but engineering. And if this object is engineered, then someone or something designed it to move this way. Even more disturbing was the discovery that these gas jets aren't pushing in random directions. They're pushing in one consistent direction, toward Mars's orbital plane, toward proximity, toward encounter. Over time, these nudges, small as they are, accumulate into something potent, a shift of hundreds of thousands of kilometers, all without rockets, without thrusters, without heat signatures, just well-timed pulses of exhaust. Imagine standing in the center of a frozen lake, throwing pebbles in one direction every few minutes. At first, you don't move, but over time, your position shifts, imperceptibly, relentlessly, until you're sliding across the surface, drawn by your own tiny efforts. That's what 3i divided by Atlas is doing, sliding. Intentionally, scientists at NASA initially chalked it up to sublimation, the sun heating volatile materials inside the object, causing gas to vent. But sublimation doesn't operate like this. It doesn't pulse. It doesn't run on timers. And it certainly doesn't maintain a rhythm that stays in sync down to the second. Enter the Mars Reconnaissance Orbiter, MRO. Its ultraviolet sensors, tasked with scanning for signs of activity on Mars, were redirected. They found something astonishing. The same 17-minute rhythm echoed in the ultraviolet range, each burst lighting up like a heartbeat in deep space. Pulse, 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 pulse. Not once, but for hours, days. It was as if something beneath the comet's shell was alive, not biologically, but mechanically, like a signal was running through it, a timer, a protocol, a schedule, and the effect was cumulative. Every pulse adjusted the trajectory. Every adjustment brought it closer, not dramatically, but precisely. Enough for orbit predictions to shift again, enough to move it into the danger zone. Still think this is coincidence? Then, consider this. Multiple amateur astronomers began to report seeing something new, needle, thin tails forming behind the comet. Not messy, not feathery, sharp, defined, all oriented in the same direction. And most bizarre of all, they too were pulsing. 17 minutes. Always 17. From backyard telescopes in Australia to digital imaging arrays in Japan, observers saw the same thing. A rhythm reverberating through the icy exhaust of an interstellar object, not drifting, not decaying. Synchronized, directed, unified. It was like the whole comet had become a machine. No known comet behaves this way. No natural object moves with such timing, precision, or deliberation. And certainly not at 87 kilometers per second, a speed that would shred most satellites if they came anywhere near it. So what are we looking at? A malfunctioning probe? A fragment of something larger? A silent scout slipping through our solar system, powered by an ancient form of propulsion we don't yet understand? One thing is becoming clear. The rhythm is not a side effect. It is the method, the signature, the language of this object. And maybe, if we're listening correctly, it's also the message. Because when you eliminate chaos, when you find rhythm in the raw, you find a mind, a pattern, a reason. And if this is reasoned, if these pulses are controlled, then we are no longer watching a comet. We are watching a decision unfold. Perhaps these 17-minute intervals are more than propulsion. Perhaps they are an algorithm, a signal to something else, or someone else. Maybe they're mapping the gravitational currents of the solar system. Maybe they're syncing with Mars. Maybe they're waiting. You feel that? That chill up your spine? That's not fear, that's recognition. Because deep down, something in us understands the sound of a clock. We know what it means when something ticks. It means something is counting towards something. Impact? Encounter? Awakening? We don't know, but we know this much. 17 minutes from now, 3 Atlas will pulse again, and the universe will move ever so slightly in response. When we stare into the stars, we're taught to look for chaos, for the natural roughness of creation. Dust, ice, radiation, chance. That's how the cosmos writes its story. Not with straight lines, but with turbulence. But 3 Atlas doesn't feel like turbulence. It feels like geometry. It's doing too many things right. Too many things that don't belong in the playbook of a drifting rock. And we're running out of excuses. The latest anomaly arrived as a whisper through the radio silence, bouncing off metal, slicing through the void, and landing with a thud at the desks of engineers at NASA's Jet Propulsion Laboratory. It came from Goldstone, one of Earth's most powerful radar installations. The deep space antennas had been retasked, aimed directly at the heart of 3i divided by Atlas, bouncing long-wave radar beams against its icy shell. The echo that returned was wrong. It wasn't the soft, scattered whisper of a dusty comet. It was sharp, reflective, metallic, like sonar hitting the hull of a submarine, or radar bouncing off spacecraft armor. It rang with the clear tones of alloy, not ice. That's not speculation. That's physics. When radar hits a natural body, like a comet or asteroid, it scatters. Ice and dust absorb some, diffuse the rest. What you get back is a fuzzy signature, a cloud. But this bounced like a mirror. It reflected. It was dense. It was not diffuse. Something at the core of 3I divided by Atlas is bouncing those beams like a bell. And the data suggests it's big, nearly 400 meters wide, with a mass close to 10 billion tons. That's not just a rock. That's a fortress. Now pair that with what we already know. Perfect 17-minute gas pulses. A narrowing trajectory toward Mars. Orbit-shifting microbursts that resemble reaction control systems. And now, a reflective metallic core. These are not coincidences. They're ingredients, a pattern, a design. Still, skeptics tried to ground the conversation. Maybe it's a high-metal asteroid, they said. Maybe there's a natural explanation. The universe is vast. But then came the spectroscopy, the chemical fingerprint. Light passed through the tail of the comet and split, like a confession under interrogation. What it revealed sent chills down the spines of the people trained not to be surprised by anything. It showed nickel, lots of it, but no iron. Let that settle. Nickel and iron are twins born together in the forges of supernovae. Every asteroid, every comet, every planet formed from star guts should have both, always. That's the rule. But 3I divided by Atlas broke it. No iron, just nickel, a pure nickel signature. That doesn't happen naturally, ever. There's only one process known to humanity that creates isolated nickel without its iron sibling, the carbonyl method, an industrial technique used to refine nickel for use in high-performance alloys. Alloys like spacecraft skin, alloys that reflect radar, alloys designed not to melt in atmospheres, or crack under stress, or corrode in radiation. Let's stop pretending. This object is not behaving like an accident of physics. It's behaving like a machine. Avi Loeb said it plainly. Nickel without iron doesn't occur in nature. It's a hallmark of intentional refinement. You can argue with astronomers. You can argue with speculation. But you can't argue with metallurgy. Nature does not selectively purify elements. It smashes things together and lets entropy sort the mess. It doesn't build elegant cores that reflect radar and pulse gas in precisely timed thrusts. Something made this, or at the very least modified it. Maybe it started as a comet. Maybe it was hijacked, hollowed out, refitted. Maybe it's the outer shell that's natural, and the inside is something else entirely, like a disguise wrapped in snow. A ghost ship, an interstellar Trojan horse. A relic from a civilization whose tools are so advanced, they don't announce themselves with flashing lights or signals, but with behavior. Behavior that only the trained eyes of scientists would recognize. As if it was meant to pass unnoticed by the masses, but not by the watchers. Maybe it's their way of saying, "We know you're watching. We want you to." And then there's the weight. The mass of 10 billion tons packed into a compact metallic heart. That's not just dense, it's dangerously stable. It means, if this thing ever does strike a planetary body like Mars, it won't just burn up. It will penetrate. It will carve through crust. It will reveal its insides. And maybe, just maybe, that's part of the plan. What if this is not a probe? What if it's a seed? What if impact is not failure, but activation? After all, the easiest way to get something to a planet's surface is to let gravity do the work. The metallic echoes, the pulse, the trajectory, the nickel, the silence, it's all adding up, not to proof, not yet, but to something worse possibility. And that's what haunts the halls of Harvard and NASA tonight, not knowing if they're watching the first confirmed alien artifact or the most elaborate cosmic coincidence in history. Because one more pulse will come in 17 minutes, and we'll still be here, waiting, listening, watching, like students before a door they dare not open. Because on the other side, might be intelligence. And it's coming closer. In the heart of a supernova, when a dying star rips itself apart, iron is born. So is nickel. They are siblings forged together in the crucible of cosmic violence. Wherever there's one, there's the other. That is the rhythm of the universe. That is the rule, until now, because 3E Atlas has defied it. It's not just reflecting radar like a machine. It's not just shifting its path like a spacecraft. It's not just pulsing gas like it knows where it's going. It's bleeding nickel, but there's no iron. Spectroscopy doesn't lie. It's the most honest language in astronomy, a map of light, color, and truth. And when the Gemini South telescope dissected the light from 3I divided by Atlas's tail, it found something profoundly wrong. Not strange, not odd, impossible. The plume carried pure nickel, isolated, vibrant, unmistakable, but there wasn't a trace of iron. None, as if someone had removed it on purpose. You might be thinking, maybe this is a fluke, maybe the iron's just hidden, waiting to be found. But that's not how astrophysics works. In every comet, asteroid, meteorite, and cosmic dust sample we've ever studied, the nickel to iron ratio holds constant, about 1:1, sometimes more iron, never less. Because the stars don't discriminate. They explode, and they share everything: carbon, oxygen, silicon, iron, nickel, a messy mix, a cocktail of elements sprayed across space. But 3E Atlas isn't messy. It's selected, as if something combed through its body, pulled out the iron like weeds, and left behind the nickel. Not for decoration, not by mistake, but for function. Nickel has properties iron does not. It resists corrosion. It withstands heat. It reflects radar. It binds with carbon to form nickel carbonyl, a rare compound used only in one place in the known universe. Here, on Earth, in factories, in aerospace labs. You see, when humans want to purify nickel to create high-performance alloys for spacecraft, deep-sea submersibles, or nuclear reactors, we use the MOND process, a chemical trick that separates nickel from iron using carbon monoxide. The result? Nickel carbonyl, a gas so precise, so delicate, it requires controlled chambers and human ingenuity to master. And now, it's in the tail of an interstellar object. Coincidence? Maybe. If you believe the cosmos is capable of running a chemical purification process billions of years old, in a vacuum, using industrial-grade conditions. Or maybe it's not a coincidence at all. Maybe it's a calling card. Harvard's Avi Loeb called attention to this anomaly in public lectures and interviews. "This is not natural," he said. "It's manufactured. Not out of arrogance, but out of discipline." Because Loeb isn't a conspiracy theorist, he's a physicist who listens to what the data whispers before it shouts. And the data is whispering this: nickel without iron is not a comet. It's a product. Think of the implications. If 3I divided by Atlas carries purified nickel carbonyl, it means it has been processed, which means it's not just old, it's used, it's part of something. A fragment, a shell, a chassis, a delivery system, a drone. It's hard to even say the words, because to say them is to invite a revolution in thought. But this is no longer a matter of belief. It's a matter of metallurgy. Imagine walking through the ruins of an ancient city and finding steel beams, riveted panels, and titanium screws buried in the sand. You don't say the wind made them. You don't say time shaped them. You say what they are: evidence. That's what nickel without iron island. It's evidence that someone, somewhere, refined this thing or part of it to serve a function. Maybe as shielding, maybe as structural support, maybe as the skin of a vessel that's meant to survive long journeys, cosmic rays, and solar fury. And then you ask the next question, the question no one wants to ask. Why is it here? Not how. Why? Because if it's industrial, it has a purpose. If it has a purpose, it has a destination. If it has a destination, and that destination seems to be Mars, then it's either delivering something, retrieving something, or studying something. And if it's none of those, then it's a relic, a long dead machine drifting across the void like a bottle in an endless ocean, hoping to wash up somewhere someone can read its message. But that's the hopeful version. The other version is darker. The other version is intentional. A functioning, precise, decision-making object approaching Mars not by accident, but by design. And if we are just now picking up its chemical scent, if we're only now realizing its skin is made of something humans use in rockets and satellites, then we're late to the party. Because whoever built it has already done what we've only begun to imagine. They've traveled, they've engineered, they've refined metal in a vacuum, they've created structures that mimic natural bodies cloaked in ice and dust, but which move, pulse, adjust, and perhaps watch. This isn't just about the tail of a comet, it's about the fingerprints of intelligence left behind in chemistry, in structure, in the ghost of a process we thought was ours. Nickel without iron is not just an element, it's a story, and we're only beginning to understand the language. Deep inside every comet is a mystery. A frozen clock wound by gravity and time, a tumble of rock and ice locked in chaotic motion. At least, that's what we used to believe. That's what every textbook says. Comets are relics, not machines. But 3 Atlas has defied too many rules, and now we're staring down a question that chills the core of scientific certainty. What if the shell is a lie? Because beneath its icy veil, 3I divided by Atlas is hiding something heavy, something solid, something wrong. Let's start with the math. The object is moving through space at nearly 90 kilometers per second, a velocity so extreme, it could tear apart most known materials on sustained impact. But 3I divided by Atlas isn't flaking, it isn't fragmenting, it's holding. That's not luck, that's integrity. Structural integrity. The kind you don't get from dust and frozen gas. The kind that implies density, cohesion, construction. When NASA's Goldstone radar returned data from a focused pulse aimed directly at the object's nucleus, the echoes startled even seasoned analysts. They weren't cloudy, broken reflections. They were sharp, high amplitude, like bouncing radar off the side of a bunker. The internal structure was compact, consistent, and unusually reflective. In fact, the density inferred from the radar signal cross-checked against infrared data and mass estimates puts the core at a mass of 10 billion tons and a diameter of roughly 400 meters. That's denser than most asteroids, denser than iron meteorites, closer to the metallic asteroids, buried in the asteroid belt, objects that have been stripped of their rocky layers, leaving only their heavy metal hearts. But those are slow-moving, old, pitted and inert. 3I divided by Atlas isn't inert. It pulses, it adjusts, it navigates. So, what if the core we're seeing isn't just dense, but engineered? Picture a hollow sphere, a vessel, not a rock, an internal framework made of refined nickel alloys, a protective shell of reflective material, and wrapped around that shell, an icy coating designed to mimic the appearance of a natural comet, complete with dust trails and sublimating gases. A disguise? Think of it as stealth tech for space. If you were building a probe to study a young, volatile solar system, to sneak into its inner planets without being immediately noticed, what better camouflage than a comet? Everyone ignores comets. They're common, predictable, harmless, until one isn't. Until one turns out to be a volt, not a snowball, a spacecraft dressed in a shroud of ice. Suddenly, that nickel carbonyl signature we detected in the tail takes on new meaning, not just a clue of construction but of maintenance, because carbonyl gases can also function as thermal regulators, internal coolants, even directional exhaust. What if the outgassing isn't just propulsion? What if it's also pressure release? A control system. Imagine a machine coasting through space, maintaining internal pressure against the vacuum, regulating temperature, emitting gas not to survive, but to adjust, to stabilize, to aim. That would explain the 17-minute pulses. That would explain the rhythmic consistency. That would explain the slowly tightening arc toward Mars, not like a rock falling, but like a hand reaching. Avi Loeb suggested that the object might be using its own sublimated exhaust to steer a primitive form of propulsion, yes, but not if it's intentional, not if it's automated, not if it's precise, because with just a bit of internal pressure modulation, 3 Atlas could mimic the maneuvering of early human spacecraft, like the Viking landers or the Voyager probes, which adjusted course with puffs of nitrogen or hydrazine, except this thing isn't from Earth, and it's much older, which leads to a terrifying question. If this is primitive to them, what's advanced? Because what we're seeing might not be cutting-edge alien tech. It might be the relic of a civilization whose real advancements are beyond our understanding. And this dense metallic probe is just the low-tier model, a throwaway, a scout, one of millions, seeded across stars to drift until caught in a gravitational field worth investigating. And if it's hollow inside, if it's not solid metal but an exoshell protecting something, then what lies within? A payload? An instrument? A memory? Or something still operational? No one knows, but some are trying to find out. There are whispers unconfirmed but persistent that the Mars Reconnaissance Orbiter is no longer just a watcher, that its cameras have been repurposed, that deep scans are underway. That Goldstone isn't the only radar dish now tracking the object's heart. Some even say that high-frequency signals have been aimed at its short bursts of radar, radio, and microwave frequencies, not to provoke, but to listen, to test for a response. None has come, yet. But silence doesn't mean absency. It could mean waiting, because if 3I divided by Atlas is what it appears to be, a vessel with a metallic core, a shell of frozen disguise, and a propulsion system that mimics cometary behavior, then it might not be designed to talk. It might be designed to watch. And if that's true, we've just become the observed. We've just become the experiment. Think about that. Right now, above your head, beyond the clouds and satellites, in the cold arc of space between Earth and Mars, a metallic heart is beating, slowly, patiently, steering, watching, adjusting. It doesn't glow, it doesn't flash, it doesn't scream, it just moves, like a thought in the dark, like a probe from a mind that built it not to be seen, but to be understood only too late. There are shapes that belong to nature, spirals in galaxies, ellipses in orbits, fractals in coastlines. And then there are shapes that don't, triangles, sharp, geometric, intentional. Nature does not favor them, not in motion, not in formation, not drifting with perfect angles through the gravitational tides of a solar system. So when European Space Agency's Mars Express returned images of 3 luminous points arranged in a flawless triangle near 3I divided by Atlas, the silence in mission control became a kind of roar. Not random debris, not ejected ice fragments, not pixel artifacts. 3 points, glowing, fixed, equidistant, and holding position frame after frame as the object accelerated through the dark. The triangle didn't drift, it didn't collapse, it didn't flutter apart like dust or gas. It held like a formation, like an escort. And suddenly, the question changed from, what is 3I divided by Atlas, to what else is with it? Engineers at ESA triple-checked the imaging data. The triangle wasn't a camera glitch. It wasn't lens flare. Multiple instruments captured the same pattern, across wavelengths, across orbits. And the triangle's orientation? Always aligned, trailing behind the comet's core like a procession, like guardian satellites, or something more. Some scientists floated the standard theories: comet fragments, detached ice chunks, perhaps pieces blown free by sublimation and held in proximity by low gravity. But there was a problem. They weren't spinning. They weren't tumbling randomly like natural debris. They were still, in relative motion with the comet's body, a kind of locked dance, steady in the chaos. And even more bizarre, they glowed with the same 17-minute rhythm. 17 minutes. The heartbeat of 3I divided by Atlas, the pulse that had already rewritten the rules of cometary behavior. And now these fragments were blinking in unison, perfectly synchronized with the main object's gas pulses. Not seconds off, not fading or drifting, perfectly timed. It was as if they were listening, or receiving, or broadcasting. Let that settle. 3 bodies, equal distance, constant orientation, blinking like beacons in a rhythm no known natural system would produce. Triangular formations don't occur by chance in orbital mechanics. There's no gravitational reason for such stability. There's no thermal reason for synchronization. The only domain where such geometry makes sense is engineering, design. In human history, we've sent missions with deployed satellites, companion cubes, relay modules, trailing drones, each designed to survey, measure, protect. Think of Apollo, Voyager, Hayabusa. We scatter tools around our spacecraft like breadcrumbs, each serving a silent function. What if this triangle is the same? Not fragments, but scouts. Not debris, but eyes. And what are they watching? Us? Mars? The Sun? Each other? Or are they watching the main vessel, ensuring its rhythm remains unbroken, its trajectory unaltered? The triangle may be more than geometry. It may be a protocol, a kind of orbital choreography, stabilizing the primary body through a trinary balance of forces, like tugs guiding a ship through a narrow harbor. And then comes the deeper fear. What if they're active? Not passive reflectors, not dead chunks, but autonomous objects with propulsion, sensors, maybe even decision-making capacity. Think of what that means: a cluster of machines from another star system, traveling not alone but as a network, a team, a fleet. Humanity has never encountered formation-flying interstellar objects before. Our best satellites can barely maintain positioning without constant adjustments. And here, in the void between Earth and Mars, a triangular pattern is drifting with perfect precision. This is coordination on a level we haven't seen, and it's not ours. Let's go deeper. If this triangle is real, and it is, and if it's coordinated, and it appears to be, then what function does it serve? 3 possibilities emerge. Navigation assistance. The triangle helps the core object correct its trajectory, acting as spatial markers, dynamic lighthouses in a gravitational sea. Observation array. The 3 points form a triangulated sensor net, allowing high-resolution mapping of Mars, Earth, or the interplanetary medium, collecting synchronized data across angles. Communication system. The formation might be a transmitter, bouncing signals between nodes in a way that mimics phased array radar or laser messaging. Any one of those would be astonishing. But there's a 4th possibility, the one no one wants to say aloud. Sentinels. If 3i divided by Atlas is a probe, the triangle could be defensive. Not weapons, not in the way we think, but something more advanced. Self-preserving systems, disruption fields, cloaking shells, interference emitters, designed to prevent interception, contact, or capture. Because what happens if we try to approach? What if Mars, with its orbiters and landers, is about to get too close? And those 3 points? They might wake up, might react, might respond. Not with aggression perhaps, not even with motion, but with silence so coordinated, it becomes an answer. Because this triangle, it isn't noise. It's not chaos. It's the opposite. It's structure. And structure is always born of thought. Imagine if, one day, your telescope found a perfectly shaped pyramid floating through space. You wouldn't say it was erosion. You'd say it was a message. This triangle is that message: silent, geometric, impossible. It's the shape of things to come. And now it's here, drifting through our solar system like a code, wrapped in comet dust and stitched into the void. We may not understand the message yet, but it's no longer waiting. It's moving. There's a reason the stars are quiet. We look up and see billions of them burning, birthing, dying, scattered across the black like celestial campfires. And yet, not one of them has spoken to us. Not a single signal, not a whisper of life. We call it the Great Silence. And perhaps it's not a mystery to be solved, but a strategy being executed. This idea, chilling, elegant, and terrifying, is known as the dark forest hypothesis, coined by Chinese science fiction author Liu Cixin and whispered through academic circles with increasing seriousness. The premise is simple. The universe, is a dark forest. Every civilization is a hunter, and silence is survival. Because in that forest, to shout your existence is to risk being hunted. To reveal your location is to invite extinction, not out of malice, but out of fear, out of strategy, out of game theory playing out over billions of years. In such a universe, intelligent life doesn't announce itself. It hides, it listens, it watches, it studies, and if it acts, it does so quietly. Now ask yourself this: what is 3 Atlas doing? It's not transmitting signals. It's not lighting up in obvious displays. It hasn't changed course dramatically to say hello. It's silent, but it pulses, it steers, it calculates, and maybe it listens. This isn't a SETI signal beamed through the void. It's not a golden record taped to the side of a satellite. This isn't Carl Sagan's hopeful voice on Voyager. This is the other kind of message, the kind sent without words, the kind not meant to be intercepted, but merely detected by those capable of seeing what lies beneath the surface. And we saw, and now we wonder, is this probe an observation platform? A test balloon? A cosmic recon drone? Something built to slip through star systems unnoticed to map gravitational wells, chemical signatures, planetary atmospheres without ever needing to declare itself? Avi Loeb thinks so. He doesn't say it with science fiction flourish. He says it with quiet urgency. He compares 3I, divided by Atlas, to a scout, a technological artifact, drifting on a trajectory that's too deliberate, too responsive, too intentional to be dismissed. And if it is a scout, then it obeys the first law of survival in a hostile cosmos. Do not reveal yourself. What's more silent than a comet? What better cover than an object that looks to nearly everyone like just another frozen rock? And what better way to understand a species like ours than to quietly drift past the systems we call home, reading our satellites, sniffing our atmospheres, measuring our emissions? We imagine alien life as curious, exuberant, eager to connect. But what if that's naive? What if they are afraid? Because we, on this tiny blue planet, have sent our signals into space for a century blind, hopeful, unfiltered. We've told the cosmos where we live. We've shared our coordinates. We've broadcast music, math, war, love, noise. And perhaps that was the mistake. Because if advanced civilizations exist, and they too know the rules of the dark forest, they would see our broadcasts not as beauty, but as recklessness. They would hear our signals the way a hunter hears a scream in the night, and then they would send something, not to respond, not to destroy, but to observe, to verify, to test the waters, to see if the ones shouting into the woods are ready to understand the cost. 3 Atlas may be that test. Its trajectory isn't a broadcast, it's a probe. Its metallic core isn't a beacon, it's a shield. Its 17-minute pulses aren't a signal, they're self-corrections. Navigational, subtle, stealthy. Think about this. If we were to design a probe to enter an alien system undetected, we wouldn't make it bright. We wouldn't make it loud. We would make it look like something they already ignore. A rock, a comet, a shadow. That's what 3I divided by. Atlas Island, a ghost in orbit, a passenger of momentum, a visitor disguised as debris. And now, after decades of silence, we've noticed it. We've seen the triangle, we've measured the nickel, we've watched the course tighten toward Mars. And we're asking the question no one ever wants to say out loud. Have we been discovered or warned? Because the dark forest doesn't just silence the reckless, it watches them. And perhaps this is our moment of reckoning, not with destruction, but with the understanding that the universe is not empty, that we are not alone, that we never were. And in this silence, amid the geometry and rhythm and metal, we find the hardest truth of all. They do not want to be found. They want to watch. They want to learn. And maybe, just maybe, they want to know if we are wise enough to do the same. If 3 are divided by Atlas is their scout, then it carries not a message, but a mirror. And when it passes us by, the only question will be, what did it see? Some warnings don't come with alarms. They come as silence that deepens, as data that stops obeying expectations, as objects that shouldn't adjust their path but do, as rhythms that count down not to impact but to understanding. And eventually, silence gives way to murmurs, murmurs give way to meetings. And then, behind sealed doors and encrypted comms, the world's space agencies sit down and ask, is this a comet or something else? In September 2025, something unprecedented occurred quietly, off the record, without fanfare. A joint emergency session was convened between NASA, ESA, Roscosmos, CNSA, and JAXA, a gathering of the most advanced spacefaring nations on Earth. The topic? Not climate change, not war, not a new asteroid impact scenario. The topic was 3E Atlas. More specifically, what it might be and what we should do about it. This was not science fiction. This was science in its most fragile moment, standing at the edge of data too strange to ignore and too dangerous to dismiss. Because by now, the facts were piling up. A supposed interstellar object, pulsing in 17-minute intervals, metallic core reflections detected by goldstone, nickel without iron, the signature of industrial refinement, triangular formations holding perfect position behind it, a tightening trajectory toward Mars, with subtle but consistent course corrections, and then, the kicker, a possible window for collision in October 2025. The world's brightest minds now faced a choice. Do we intervene, or do we watch? To intervene meant mounting a mission fast, using Mars-based assets, not Earth-launched interceptors. A direct launch from Earth would require a delta V of nearly 24 kilometers per second, a Herculean task, virtually impossible with current propulsion systems in such a short window. But from Mars, from orbiters already in place, it might be possible. The Mars Reconnaissance Orbiter, Mars Odyssey, and even ESA's Mars Express had the hardware aging, yes, but still functional. The question was whether they could be repurposed to perform a flyby, a close-range scan, or if necessary some form of interception. But interception of what? A comet? Or an artifact? The problem wasn't technical, it was philosophical. Because what if we're not dealing with a threat, but with a messenger? To touch it might be to destroy it. To observe it might be too late. To ignore it might be catastrophic. Every agency had a different opinion. NASA, driven by scientific rigor, leaned toward passive observation to gather data without disturbing the object. ESA urged caution, but emphasized the need for rapid deployment of spectral and imaging assets from Mars orbit. Roscosmos floated an ambitious but risky proposal to use gravitational slingshot techniques and a high-speed flyby to get closer than ever before. CNSA reportedly had already aimed a deep space antenna array toward the object weeks before the meeting, receiving unusual electromagnetic patterns that weren't made public. JAXA, with its experience in sample return missions like Hayabusa, suggested the unthinkable, a collection attempt if 3I divided by Atlas passed close enough. But none of these ideas were decisions. They were possibilities wrapped in uncertainty, because no one wanted to be the first to act, not when the object might be listening. What if it was built to react? What if it interprets pursuit as hostility? The dark forest logic once again haunted the discussion. To send a probe toward a probe to pierce the veil of silence with action might be the exact opposite of what wisdom demands. And yet, to do nothing? To simply let it pass? That would be a tragedy of missed understanding, a cosmic ship gliding silently past, never to return, a gift from the stars, unopened. So the debate split into two factions. The interventionists, who argued this was a one-time opportunity to study something truly interstellar, possibly artificial to get answers to questions we've been asking for centuries. The preservationists, who warned that to interact with something you do not understand, especially if it might be sentient or surveilling, is to invite unintended consequences. In the end, no consensus was reached, but a strategy was. Passive escalation. Satellites and orbiters around Mars would be repurposed to observe, track, and scan 3I divided by Atlas during its closest approach. No intercept missions, no probes launched, just eyes. silent observation, full spectrum monitoring, readiness to act if something changed. But they also made another decision, one not recorded in public documents, to keep most of this from the public. Why? Because if 3I divided by Atlas was confirmed to be artificial, if the evidence became undeniable, the psychological shock could eclipse any scientific breakthrough. Civilization has always believed it was being watched by gods, angels, demons, or stars. What happens when that belief shifts to something real, something measurable, something here? What happens when the gods turn out to be engineers? So the press releases stayed careful, the language stayed clinical, unusual cometary activity, unanticipated trajectory adjustment, minor compositional anomalies. But behind those phrases was a room full of people who now believed the impossible had become likely. And in that room, someone asked, probably softly, probably in private, what if this is the first contact and it doesn't want to talk? Because contact doesn't always begin with words. Sometimes it begins with an approach, a pause, a glance. Sometimes it begins with a test. And maybe, just maybe, 3 Atlas is that test. And we are the ones being evaluated. This is where the story shifts. From space to us. From the object to the observer. From what it is to who we are in the face of it. Because when the universe sends something like 3 Atlas into our neighborhood, something moving with rhythm, cloaked in silence, forged from improbable metal and mathematics, it is not just a test of physics. It's a test of character. And now, humanity stands at a crossroads, not of technology, but of intention. Do we intercept, or do we observe? This is not a scientific decision. It is a mirror held up to a species that has spent its short existence shouting into the void, launching metal into orbit, beaming greetings to stars, firing questions like arrows into blackness. And now, maybe for the first time, the void has sent something back. It doesn't answer. It doesn't blink. It doesn't declare its purpose. It just moves, closer, quietly, deliberately, and the silence asks us, what kind of civilization are you? The answer depends on what we choose to do next. The case to intercept. For many in the scientific community, the opportunity is too rare to ignore. This is a once-in-a-millennium event, a possible artificial object from beyond our solar system, passing close enough to be studied, maybe even touched. To send a flyby mission, a probe, a lander, even a spectrometer mounted on a Mars orbiter would be a revolution. We could scan its interior, test its chemistry up close, try to decode its structure, its motion, its reason for being. What if we could confirm its artificial nature? What if we could prove, beyond theory and speculation, that something out there builds? What if, hidden beneath the ice and carbon, there are circuits, reactors, memory banks, instruction codes? To intercept it might mean understanding, and understanding, to some, is worth any risk. The case to observe, but others speak with caution, with reverence, even with fear, because to intercept means to announce ourselves not just to the object, but to whatever may be listening through it. If this is a probe, it is not alone. If this is a scout, it reports to something. If this is a messenger, it has not yet delivered its message. What happens when the subject turns the microscope on the scientist? What happens when we become the experiment? There's a haunting truth in the dark forest, that silence is the strategy of the wise, and by reaching out, by launching toward this object, we risk violating the protocol that might be keeping us alive. Because no matter how silent 3I divided by Atlas has been, it may be watching. It may be waiting to see what we do next. Will we approach with curiosity, with reverence, with aggression? Do we reach out, or do we stay still and watch it pass? The technological barrier. Even if we wanted to intercept, the challenge is enormous. From Earth, we'd need propulsion tech that doesn't exist, at least not publicly. A delta V of 24 kilometers per second to catch up from here is more than our fastest rockets can dream. But Mars offers a loophole. With its lower gravity and proximity to 3, I divided by Atlas's flyby path, a Mars-based intercept would only require about 5 kilometers per second of delta V. That's within range, barely. If we reconfigure one of our older orbiters, redirect a lander, or use an atmospheric slingshot, we might just get close enough. But then what? What do we do when we get there? Do we land? Do we drill? Do we pierce the veil? And can we live with what happens next? The existential question. Because beneath all the calculations and mission proposals lies a deeper inquiry, not about comets or crafts, but about us. Are we ready to meet what built this? Are we ready to accept that we are not the first, not the oldest, not the smartest? Are we ready to approach something that might look at us the way we look at ants, with curiosity but not equivalence? And if we are not ready, if we still tear ourselves apart on the surface of our own world, if we still argue over borders while the stars remain silent, then perhaps we are not yet worthy of interception. Perhaps observation is not caution. Perhaps observation is humility. To watch this object pass, to study its silence, to collect its rhythm, its reflections, its tail of nickel and pulse of gas, to do that without disturbing it, without shouting again into the woods. That may be the wisest thing we've ever done, because wisdom is not just knowledge, it is knowing when not to act, knowing when to kneel before something you don't yet understand, and to let it pass like a storm or a god. The decision the agencies have chosen, at least for now, they will observe. No intercept, no landing, no breach. They will watch, record, map, and listen. They will let 3I divided by Atlas glide past Mars untouched unless something changes. Unless the object chooses to act, because now the question is no longer whether we will intercept it. It's whether it has already intercepted us. There's a moment in every storm when the wind pauses, the sky holds its breath, and something ancient in your bones whispers, "This is going to hit." For months, we've watched 3 Atlas close the distance from 29 million kilometers to less than 2. We've measured the trajectory shifts, the micropulses, the orbital plane alignments. We've seen it nudge itself, rhythmically, closer to Mars, not with fury, with precision, like a chess piece gliding across a cosmic board, one square at a time, toward its final position. And now the models speak plainly. If it gets a final push, if a single gas burst lands just right, if Mars's gravity does the rest, then this isn't a flyby, it's a collision. Let's be clear, this isn't a splash in the dust. This isn't a meteorite skipping off atmosphere or burning in a blaze. This is something else. 3I divided by Atlas is 400 meters across a compacted core of potentially engineered metal, wrapped in comet dust, traveling at 57 kilometers per second relative to Mars. That's faster than any bullet, faster than any missile, faster than anything humans have ever launched or survived. At that velocity, mass becomes a weapon, motion becomes destiny. If 3I divided by Atlas hits Mars, it will unleash the energy of 2 million megatons of TNT. Let that number breathe. That's 133 million times the force of the Hiroshima bomb. Enough to vaporize cities. Enough to redefine landscapes. And on Mars, with no oceans to absorb shock, no thick atmosphere to cushion impact, the event would be pure, raw violence. The crater. Simulations show a resulting crater 60 kilometers wide and 5 kilometers deep, a scar in the Martian crust visible from orbit, from Earth, perhaps from anywhere in the solar system with the right lens. It would rival Hellas Planitia, dwarfing most impact sites ever observed. The explosion would hurl billions of tons of rock and dust into the atmosphere, sending shockwaves rippling across the planet, disrupting dust cycles, blocking solar radiation for weeks, maybe months. And here's the terrifying twist. Mars has no plate tectonics, which means that scar, that impact basin, it wouldn't heal. It would remain, permanently, as a monument to the moment the solar system changed, the fallout. But it's not just Mars that pays the price. Every orbiting asset, every satellite, rover, drone would be in danger. Perseverance, Ingenuity, Mars Reconnaissance Orbiter, Mars Odyssey, Tianwen-1, Hope, ExoMars, all of them could be obliterated by ejecta, caught in the debris field, or fried by plasma bursts as material vaporizes. Decades of exploration, billions of dollars, a generation of Martian science, gone in an instant. The Martian sky would turn black with dust, instruments would go silent, communications would scatter, and Earth would be left staring at a world suddenly transformed not by time, not by tectonics, not by nature, but by an object that may not be natural at all. Earth isn't safe either. Here's where it gets cosmic. An impact of that scale, at that speed, doesn't just explode, it ejects. Debris wouldn't just settle into Mars's sky. Some of it would escape gravity entirely, launching fragments into solar orbit. Some would fall into the asteroid belt, some would drift toward Jupiter, and some might find their way back to us. Not tomorrow, not next year, but within a decade. Fragments from a 3E Atlas Mars collision could reach Earth's orbital path. Dust, rock, shrapnel, metal, some of it microscopic, some of it large enough to be tracked. The odds of impact here? Small. The risks? Unpredictable. But that's not the part that haunts scientists. What haunts them is the possibility that the object contains exotic materials, or non-earthly microbes, or nanostructures. Or most haunting of all that, its detonation could release mechanisms we weren't meant to see. Imagine shattering an alien device. Imagine watching it fracture, not explode, revealing layers, chambers, compartments, seams in the metal not caused by pressure, but by design. It wouldn't be a disaster. It would be disclosure, a forced autopsy, a cosmic reveal. Suddenly, all those quiet behaviors, the 17-minute pulses, the nickel carbonyl shell, the triangular escort probes wouldn't be mysteries anymore. They would be clues, and we would finally know this wasn't a rock, it was a craft, scientific goldmine, existential gamble. The paradox is brutal. If 3I divided by Atlas misses Mars, we may never know what it truly island. But if it hits, we might learn everything too fast, too violently, too late. The energy released could crack open its core, spilling secrets that instruments have only guessed at. We might uncover refined metals unknown on Earth, or alloys fused under conditions no planet can produce, or technological remnants, the shattered bones of something sent long ago by minds not our own. But at what cost? Do we gamble a planet's orbiters, a century of research, the safety of our solar system just for the chance to see inside? That's the choice before us. A comet, a probe, a weapon, a messenger. Whatever it is, it's moving too fast to stop, and we are no longer in control. We are the bystanders, the archaeologists, the ones at the edge of the impact zone, holding instruments and questions, waiting for the moment when data becomes crater, when trajectory becomes event, when silence becomes impact. And if it hits, the sky over Mars will bloom with light, and the universe will whisper one final question into our trembling ears. Did you think I wouldn't answer? When something strikes a planet at 57 kilometers per second, it doesn't just leave a crater, it leaves a trail, a shockwave, a wound, and a legacy of debris flung into space like shattered secrets. If 3 Atlas impacts Mars, it won't die quietly. It will detonate, and in doing so, it may scatter pieces of itself and of Mars into the void. And some of that debris could come here. Let's follow the arc. The energy of the impact, 2 million megatons, would vaporize the point of contact, cracking open the crust, throwing molten rock, dust, ice, and whatever lies within 3I divided by Atlas into suborbital arcs. Most of it would rain back down in a hellish storm, but a portion, perhaps 1–2%, would be launched fast enough to escape Mars's gravity completely. Those fragments would enter heliocentric orbit, free-floating across the solar system like cosmic seeds. Some would fall into the asteroid belt, some would slingshot around Jupiter, some might spiral into the Sunday, but a few, the ones flung in the wrong direction at just the right speed, would begin a long, slow journey across Earth's orbital path. They could arrive in 10 years, maybe less. Some would be sand grains small, undetectable until they entered our atmosphere in streaks of light. But others, hunks of metal, mineral, or something entirely unknown, might be large enough to survive re-entry. Imagine that. A piece of 3I divided by Atlas, forged in another star system, shattered by a Martian impact, now lying on the floor of Earth's ocean, or embedded in Antarctic ice, or glowing in the soil of a desert crater. A fragment of alien architecture, delivered by accident, written in alloy. And here's the chilling thought. This has happened before. Earth has collected Martian meteorites, rock fragments blasted off the red planet millions of years ago, thrown into space by impacts, and later captured by our gravity. Some sit in museums. Some have been sliced thin and studied. One even sparked controversy when scientists claimed to find fossil-like structures. So we already know it's possible. But this would be different. This wouldn't be a rock. It could be refined metal, or composite materials, or micro-machines the size of dust particles, or worse, something alive. Not alive in the biological sense, but in the way viruses are alive, in the way software is alive, in the way seeds are alive. What if a fragment of 3I divided by Atlas carries programming? Not radio, not messages, but code written in chemistry, structure, or quantum spin. Something designed not to communicate, but to activate. You might laugh. That's fiction, you say. That's Hollywood. But ask yourself this. What happens if we collect such a fragment, crack it open under a microscope, and find order, find patterns, find symbols etched into the molecular lattice? Not writing, but symmetry, intent. What if the material isn't passive? What if it responds? We aren't prepared for that. Our labs aren't sterilized for exo-industrial debris. Our computers aren't secured against hardware we didn't build. Our minds aren't trained to process the idea that a piece of Mars may now hold a piece of something else. A technology that survived interstellar travel. A system that endured impact at impossible speeds. A fragment of thought, encoded in metal, drifting toward Earth. And it doesn't have to land. Just entering our atmosphere, it could scatter molecules, spread isotopes, introduce materials that behave differently, reflectively, magnetically, biologically. This is why planetary defense isn't just about stopping collisions anymore. It's about understanding what comes after. And this time, it's not Earth at risk, it's Mars. We're the observers, but we're also next in line. The contamination dilemma. Now flip the perspective. What if the danger isn't what 3I divided by Atlas brings to Mars, but what Mars gives back? Billions of tons of Martian crust, ancient soil, frozen microbes, chemical signatures flung into space, some of it sterilized by heat, but some of it shielded inside ejected rock. And what happens if Martian bacteria, fossilized spores, or unknown biochemistry hitches a ride to Earth? The last time this happened, it was nature's doing. This time it might be engineering's. And if 3I divided by Atlas contains sealed chambers, internal volumes that survive the impact, then what spills out isn't just science. It's risk. Risk of contamination. Risk of activation. Risk of opening something we were never meant to find. That's why some researchers are calling this the reverse panspermia event, not life seeding Earth, but a collision reverse, seeding the solar system with debris from 2 planets and possibly 1 machine. And Earth is downwind. What do? The agencies know this. Quietly, preparations have begun. Spectral mapping arrays on the moon. Deep space debris tracking algorithms added to telescopes. Antarctic detection protocols for anomalous meteorites. Even private aerospace firms are being looped in, asked to watch for micro-impacts during re-entry of returning satellites. Not because we expect catastrophe, but because we suspect something might be coming. And if it does, if it lands, then it will fall not as a light in the sky, but as a question. What are we supposed to learn from this? Because it won't be just data. It will be proof. Proof that we are not alone. Proof that something out there builds. And maybe, just maybe, proof that they've been here before. or that we are the next step in a journey that began far beyond what we can see. Fragments will come: shrapnel, ash, metal, pieces of Mars, pieces of 3I divided by Atlas, and maybe pieces of a message too large to arrive all at once. We spend our lives chasing the surface of things, the shell, the crust, the silhouette, the numbers. We orbit, meaning like satellites, always close, rarely touching. But once in a generation, something breaks. And when it breaks, we see inside. If 3 Atlas collides with Mars, it will not vanish. It will shatter, and in that moment, a fraction of a second, frozen in the eyes of every telescope, we may finally see what it has kept hidden for millions of kilometers. Because ice doesn't matter, dust doesn't matter. What matters is the core, the heart, the secret. And if the object is artificial, even partially, then the impact won't just be an end. It will be an opening, the autopsy of an artifact. Imagine the violence. A 400-meter metallic mass strikes the Martian crust at 57 kilometers per second. The outer shell vaporizes instantly. But if the core is dense, a forged alloy, a hollow vessel, a reinforced internal structure, it might survive the shockwave, at least partially. It would crack, it would twist, but it wouldn't disappear. It would reveal, debris would scatter. Some of it would be raw material, vaporized rock, scorched nickel, silicates. But mixed within that chaos, perhaps, are pieces of a design, plates, supports, chambers, inscribed internal components, not alphabet, but geometry. Because if this was a machine, it was built not for beauty, but for resilience. And what we might find in its fractured core is something that's never been seen. A cross-section of alien engineering, not dreams, not drawings, but hardware. This wouldn't be like a crashed aircraft we can reverse engineer. It would be an alien logic, built atom by atom, forged for purposes we haven't evolved to understand. Just touching it might raise questions we don't know how to ask. Would there be interior symmetries? Would it contain nested chambers, each one smaller, more precise than the last? Would it hold a central processor or something more exotic, something biomechanical? Or is the whole object itself a kind of living computer, encoded not in silicon, but in quantum geometry? Would we recognize a blueprint, or just marvel at intent? This is the real prize. Not the crater, but the core, material revelation. Already, we've seen hints. The nickel without iron, the radar reflections, the spectral anomalies. But these are footprints, shadows, impressions on the cave wall. An impact would deliver the raw material. With sensors trained on the detonation zone high-resolution cameras, mass spectrometers, radiometers, we could analyze the debris in real time. Light curves would tell us temperatures. Emission spectra would expose compound structures. Subsurface echoes could map density gradients in the broken remains. But there's more. What if the impact activates something? Not in the Hollywood sense, no flashing lights, no sudden transmissions, but a chemical trigger, released only when pressure drops or magnetic fields collapse. A layered chamber, sealed until the outer hull is breached. Inside, a substance not known on Earth, a lattice too symmetrical to be natural, an isotope that defies decay. It wouldn't have to glow, it would only have to exist. That would be enough to change everything, because in one instant, the universe would go from maybe we're alone to we are not the first. And that shift would echo across every lab, every government, every classroom, every child who looks up at the stars and wonders who else has looked back. The ethics of knowing. But with revelation comes risk. What do we do with what we find? Do we keep it secret? Weaponize it? Study it in silence? Declare it to the world? The object may not offer answers in language, but its form, its fracture will speak. The way an insect's wing speaks of flight, the way a circuit board speaks of thought. We must be careful, because this would not be a discovery. It would be a first contact autopsy. And the ethics of dissecting a fallen visitor, even one that says nothing, even one that is long dead, are delicate. What if we're meant to find it this way? What if the object was designed to break open on impact, like a seed pod, exploding only when struck hard enough by a planet's crust? What if the impact itself is the key, not failure, but invitation, a one-time doorway, a test of readiness, a challenge written in orbital mechanics and silence? The moment it fractures, we may learn why it came, not to contact, not to communicate, but to see what we would do when the unknown arrives broken at our feet. Would we be curious or terrified? Would we destroy what remains or cradle it like the relic of a forgotten god? Because in that moment when we see inside, it won't be about them. It will be about us, a message beyond language. Let's go deeper. What if the message isn't words? What if the message is the material? A message written in ratios of isotopes, the precision of bolt alignments, the gaps between components like musical notes made of silence, the phase of crystals, the deliberate absence of randomness. Not something we can read, but something we can recognize. Intent, intelligence, pattern, engineering. It may take decades to understand, centuries even, but we would know, in that first instant of impact as dust rises and instruments scream, that we've seen something not shaped by wind, or time, or chance. We've seen something built, and in that, we will be different forever. The universe will no longer be silent, because the silence was always the casing, and the casing has finally cracked. Not everything strange is artificial. Not everything symmetrical is designed, but at some point, randomness fails, and what you're left with is a decision to cross the line, to say it out loud, to point at something and declare, with trembling certainty, this was built. But what makes a thing artificial? Is it the material, the motion, the purpose, the pattern? Or is it the feeling you get when you know deep down that the universe doesn't move like this on its own? We've seen comets before, thousands, but 3 Atlas defies them all. We've measured its nickel signature, free of iron, industrial, not cosmic, its radar reflections, sharp and dense like armor, its pulses, every 17 minutes machine-like, unwavering, its escorts floating in a perfect triangle formation, not fragments, its trajectory tightening with each pass responsive, not random. And now, we may soon see its interior fractured open by impact, revealing layers, chambers, seams, or something more cryptic. But how do we really know that this object is artificial? Because that word carries weight. To call something an artifact is to cross a threshold of belief. It's to say, this is no longer natural. This is evidence of mind. So what counts as evidence? Is it engineering? Is it math? Is it anomaly stacked upon anomaly until coincidence collapses? Or is it something more primal, a recognition that surpasses language? Because artificiality isn't just in the material, it's in the relationships between things. Distances held constant, angles preserved, timing repeated beyond natural tolerance, matter arranged with too much intention to be noise. It's not just that 3 Atlas is strange, it's that it is strange in ways that overlap rhythm, geometry, chemistry, trajectory, all converging on a pattern that screams design, and not human design, not even earthly, design that echoes intelligence, design without declaration, design that hides in the open, cloaked in comet dust and cosmic velocity. What if we're wrong? Of course, there are skeptics. There must be. They say, just because it pulses doesn't mean it's a machine. Just because it contains nickel doesn't mean it was refined. Just because it's heading toward Mars doesn't mean it's aiming. And that's fair, because science isn't belief, it's process. It demands restraint. It requires doubt. It thrives on the edge between theory and proof. But here's the thing. When you find one anomaly, you wait. When you find 2, you investigate. But when you find a cascade of impossible things, all in one object, all aligned toward motion and pattern and material that reflect intent, then at some point, science doesn't retreat. It crosses over. It dares to say the words. And in doing so, it grows, because science is not the denial of wonder. It is its most powerful expression. Built, but by whom? If we declare 3 Atlas artificial, the next question forms like ice in your veins. Who built it? A species? A machine? A civilization long vanished? A post-biological intelligence? An ancient AI, drifting between stars for eons? Perhaps it was launched not to us, but through us, a long-dead message continuing its trajectory out of inertia and mission. Or maybe it wasn't built for us at all. Maybe it was built for anyone, any system, any star, any planet that reached a level of curiosity just high enough to notice its strange behaviors and ask the same question we're asking now. Are we being watched? Because maybe it doesn't want to be understood. Maybe it wants to see who tries. What kind of mind pauses at the 17-minute rhythm? What kind of species repoints telescopes? What kind of civilization holds back an intercept mission out of humility? Maybe the artifact isn't the message. Maybe we are the message. Maybe we were always part of the test. A new definition of intelligence. What if intelligence isn't measured by technology, but by restraint? What if the way you treat the unknown becomes your passport to the galactic stage? In our stories, we reach for the stars. We beam messages. We ask to be seen. We dream of contact. But what if the ones who matter are not looking for loudness? What if they're looking for pattern recognition, emotional discipline, patience, the ability to see complexity without fear, the willingness to say, we don't know but we care? That's what 3i divided by Atlas may be measuring. Not our intelligence, but our wisdom, because anyone can build rockets. But not everyone can look into the face of a possible machine traveling through space, cloaked in silence, and say, let it pass, let it choose. That's what makes a thing built. Not just material, but meaning. Not just structure, but suspicion that becomes awe. And when awe deepens into humility, that's when you know this isn't just an object, it's a story, and we're inside it. The comet is still moving. It hasn't stopped, hasn't spoken, hasn't turned. It simply continues pulsing every 17 minutes, trailing its silent triangle through the dark, sliding along a path that may or may not end in impact. And we are left watching, not as conquerors, not as children, but as witnesses, because that's what this moment truly is. A threshold, a line drawn not in the sand, but in the stars. A point in time when the question of who we are met the possibility of who else might be. And it asked us, will you see me clearly, or only project yourselves onto me? 3 Atlas doesn't carry a plaque. It doesn't broadcast math. It doesn't shout peace. Its message is something far more ancient. It says, watch me, watch how I move, watch how I wait. And from your watching, you will learn what kind of eyes you truly have. Because the deeper truth of this journey, the one that echoes louder than megatons and brighter than plasma, is that we are not just discovering something out there. We are discovering something within. The way we respond to mystery reveals the shape of our soul. Some of us demanded answers. Some of us feared the unknown. Some of us whispered prayers. Some of us simply stared in awe. All of us in our own way reached out, and that reaching is what makes us human. The universe is not empty. This story began with a dot of light, just another blip on a star map. Now, it has become a mirror, because whether 3 Atlas is a comet or a craft, whether it hits Mars or sails into deep space, whether it's ancient technology or natural anomaly, doesn't change what it's done to us. It has forced us to look up again, not just to see, but to wonder. And that is the beginning of all consciousness. Perhaps that was the point all along. Not contact, not collision, but contemplation. A slow dance between the known and the unknowable, orchestrated not by sound but by silence. Because silence can be an answer, so can motion, so can pattern, so can a question that refuses to end. 3 Atlas never said a word, but it changed everything. It shook the scaffolding of certainty. It tested the integrity of science. It cracked open the vault of imagination. And in doing so, it reminded us, you are not alone. You are not the center. And you are not yet finished becoming who you are meant to be. What happens next? We don't know. That's the gift. And the terror, if it misses Mars, it will vanish into the black, a ghost ship, its tail unfinished, its secrets intact. And for the rest of our lives, we'll wonder, was that our moment? If it hits and fractures, then perhaps we'll finally glimpse what's inside. Perhaps we'll find answers so strange, they will take lifetimes to decode. Or perhaps we'll find only more questions, nested like Russian dolls, each deeper than the last. Maybe it'll be forgotten. Maybe it'll be remembered as the day the silence almost broke. Or maybe, one day, we'll build our own 3 atlas and send it drifting to some other star, hoping another civilization will see its rhythm, its triangle, its strange and silent dance, and ask the same thing we're asking now. Is anyone else out there watching? The final question, because in the end, this was never about the object. It was about us, our eyes, our minds, our patience, our hunger for meaning. In the cold machinery of the cosmos, 3 Atlas didn't change the universe. It revealed that the universe was always stranger than we dared believe, and that we, the dreamers, the skeptics, the poets, the scientists, are standing at the edge of something vast, ancient, intelligent, and silent. A place where answers don't come easily, where truths unfold slowly, and where the first lesson of contact is how to listen. So now we ask not as explorers, but as witnesses. Did we just see an object pass through our solar system? Or did we just pass through a moment that will echo for the rest of our species' history? We don't know, but we were here. We looked up. We felt it. We asked the question. And sometimes, in a universe full of silence, that's how the story begins.